What is going on, everybody? In this video we're going to show how to get Tesseract going on a Windows machine and how you can use Python to interact with it. So let's jump right in. So Tesseract is OCR, optical character recognition, which is good for extracting text from things like PNGs and JPEGs and other image formats as well. So the first thing we're going to do is import pytesseract. But as you can see, it is not installed. So we just need to pip install pytesseract. Not Tesseract. There is a package out there on PyPy, but it looks like that hasn't been updated since around 2015. Didn't really look too deeply into it, so not sure what that is. All right. So now that we have pytesseract there, we can go ahead and read an image in. But to do that, we're going to need two pieces here. We're going to need actually Tesseract, and we are going to need an image to read in. So first we're going to do Tesseract download. And if we just go to the dock, and we'll go ahead and do UB Mannheim and download the executable. And I forget the syntax of reading in the text. Python Tesseract, read text from image. And it looks like that might be doing some kind of conversion there. That's showing command line. It's not what I'm looking for. Let's go ahead and kick off the installer. And while that's going, we'll see if we can find that command. It's just me on this PC, so I will select just my user, install that. Don't really need that. See if that's finished. There we go. Let me do pytesseract. I want to say it's text from image. Hopefully that'll give us a better result. And we'll need that command as well. Image to string, that's what it is. So I'm just going to go ahead and copy that. And we'll put that in the cell below. I'm going to call that variable text. And this is where our image will go. So now that we have Tesseract installed, we need to tell Python where it can find it. So we just need to add that to path. Since I installed it just for my user, I'll go to users and hidden items. It's probably in app data. There we are. And I'm going to copy that. We need to add that to environmental variables just so the computer knows where to find it. And I'm just going to do this for my path. Put that in there. And now if we open up a command prompt, if you choose to do it that way, we should just be able to do Tesseract and you see it's calling the executable in that directory. Okay, so there is one other piece that we'll need, and we need to tell Python where to find that executable. We will need to quote that, and because Python and Windows don't use the same directory separators like that, we just need to tilt them the other way, and I believe that's tesseract.exe. And we saw in that post the command that we'll need. There we go. pytesseract.pytesseract tesseract command. And we'll just spin back here. All right. So now we need an image. Let's do human services. Usually they've got forms and such. And doesn't really matter. I'm going to do mental health. And we can just go ahead, download that. What is this one called? We'll call that. I should have left that the same. I'm just going to call this Form 1. And the only reason I'm not naming it any words in here, because I don't want you to get confused thinking somehow the file name is tipping that off. And I can go ahead and just put that in documents, as well as I should have put this one in documents as well. So now in Visual Studio Code, we have those forms. Okay, let's go ahead and read that in. So we'll do form1.pdf, and we get a big screeching error here. PDF is not supported. So, as I said, Tesseract is going to extract text from images, not PDF files. There are ways you can convert PDFs to image files programmatically with Python, as well as other tools. But for this demo, we'll just go ahead and open those and take a quick snip. Just going to use Google Chrome and look for the snipping tool. And that's good enough. Call this Form 1. And we close that. Oh, and actually that one's still up. That's convenient. We can just grab a snip. And we'll call that Form 2. I need to fix that name. F2. That should be Form 1. Okay. So we just need to change that extension to PNG. And we can see that it is reading in the text from that image. So how can this be useful to us? Well, let's say we're trying to classify a bunch of documents. And we know that documents have certain phrasing printed on them. We could run a tool to convert them into images, or maybe they come in as images. People taking pictures with their camera phones and emailing them in. So what we can do is we could make a function here, and we can see that this one has enrollment, and we can see that this one has responsibility in it. We could do and service plan. Might get into the weeds a little bit, might insert some characters between the words, so we'd need to kind of look at those. You could scan through all the documents, make a set to make sure all of those are unique, grab a substring of the text that's read in, find similarities, and do it that way. But let's keep going with this example. We can make a function, classified doc, that's just going to take in a file name. And then it's going to go ahead and use that to make our text. And here we will do file name. And we'll say if enrollment, because we see that there, and we will want to convert the text to lowercase, just in case it thinks some are capital and some are uppercase. I'll just normalize it like that. And I forgot my in. We'll say return enrollment. Elif, put that on the same level. Oh, usually I forget my semicolons. Responsibility in text.lower, return responsibility ability in text.lower. Oh, I did not get enough sleep. Okay. Else return unknown doc type. And then we can make that function and we can just run it on either one of these. So I honestly forget which is which, but that is enrollment. That is, oh, unknown. Something tells me I misspelled responsibility. Okay, there was a typo in there. And then if we just go ahead and actually we can just do CNN, and we'll just grab a snip here. And if you're kind of new to programming in general, do not think this would be the way to get website data. You would want to do web scraping, use something like Beautiful Soup, actually parse the HTML data to actually get the words from the website, things like that. Maybe if you were doing bug bounties, penetration testing, and I can't recall the name of the tool, FireEye, I think it is, where you give it a list of URLs and it returns a bunch of screenshots of all the websites. That might be a time where you'd want to use a tool like this. So, you know, there's certain versions of web servers that are vulnerable, that have certain text that displays on the default web page. You could definitely use this to kind of sift through those and see if any known vulnerability default web servers were running. But that's enough of that tangent, and now we can go back to our code and that is an unknown doc type. Actually, just out of curiosity, I want to see what's in that text. So we could have put world politics in there and said, hey, that's CNN, and so on. Okay, so where would we go from here? Let's go ahead and we will make some directories. We're just going to make enrollment. We'll make a responsibility. We will make a unknown. And you know what? Let's go ahead and make an error directory. I really should have made a directory specifically for this project. Sorry, the default Windows folders are kind of muddying the waters over here. So what we can do is we can go ahead and use shutil, which is a package that allows us to move around files and interact with the file system in just a nice kind of way. So what we could do is, if enrollment is in there, we want to shutil.move. What do we want to move? The file name that was given, and we want to move that to, we'll use an F string and just do the current directory into enrollment, and we want to keep the file name, so we'll just file name, and we can just copy that, move that down, but that will be responsibility. And otherwise, we can go to the unknown directory. We will actually, we can make a list and just type out the names of these files, but we could use the OS package, which is a built-in package in Python, and we can just import that. And I believe the syntax is for root dir file in os.walk, and dot being the current directory. So if I was in another directory and I wanted to search a directory where I'm not writing my code, I would do the c:/users, or say it's a network drive, say a G drive that's mapped, but in our case it's all right here. So and actually I probably want to do files and then for file in files, because I believe files returns a list, and I'm just going to go ahead and confirm that by printing out file. Okay. And with this, I could say if, let's see, .png in file.lower print file. And there's our PNG files. So I could say, okay, if it's a PNG file, I'm going to go ahead and run this function on it. And if we look now, no errors, unknown is indeed our CNN, responsibility was found in form 2. And the reason I put errors in there, we can move these back just to give us a reset. You know what, I'm gonna click that so it quits asking me. If I go ahead and make a new file, error.png, with image files, I mean, it's all code. So at the beginning, typically there's hexadecimal, and whether you have the extension or not, it tips you off into what kind of file it is. So you can, trying to think of how to phrase that. So you can kind of move a slider if you know what hex codes to look like, whether they be 8 hex codes long or 4 hex codes long. And that's kind of computer forensics. When people delete files, there's no pointer in the file system to those images anymore, but there are tools out there that let you go through the hard disk where there's no pointer to it saying, hey, there's a file here, but then if you see that specific series of hex codes, you can be pretty sure that that's an image file. Read till the end of the hex code. Sometimes it's overwritten, but anyways, I expect this to fail, and that's what I want to demonstrate here. So let's go ahead and we will go ahead and not really sure why I got that error. But let's go ahead and we are just going to run it on the one error file. And actually, I'm going to make a file list, modularize this a little bit, and I'm just going to say file list dot append, and what do I want to append? The file. So then if we look at file list, okay, and if we just do error.png, okay, so how do we handle when an image comes in and it's not really an image? Well, we can do a try and exception. We will do try, and rather than crashing in a horribly ugly error code, we'll go ahead and catch that. And we can do accept exception as E, and you know what, we will just move that to the error directory. What do we want to move? The file name we gave it. Where do we want to move it? Lowercase f. We want to move it to the errors, and we will keep the file name. And you could improve on this a little bit. You could have a maybe an error log file, let you just kind of look at a glance what files errored out, so you could look and then deal with them as needed. And now if we go ahead and run this, well, we shouldn't have gotten that. Oh, I probably need to rerun that to update the function. Text where it's not associated with a value. Oh. And oh, it did move it, but then it continued with our code. So what happened was it tried it, it hit the exception, it did what it was supposed to do here, and it moved the file, but you know what? It never, the reason we got the exception was it wasn't able to read the text. And then it went down here and said, okay, for text, and wait a second, I don't have a variable named text. What are you doing? So if we try that again now, all right, no error. We do get a -1, just kind of a hint for us saying, hey, something went wrong, and it was moved to the errors directory. And these return codes, depending on the size of the code you're writing, can be very useful. So say I've got 500 lines of code and I make this one 55. Well, if I'm running this program and I see, hey, it returned -55, well, I can go into the code and say, hey, this is the part of my code that returns -55. Something is triggering it. What's going on here? But I'll just leave that at -1 for now. Make sure that that is up to date. We have that piece there. Our file list should still be the same. And then I could just do for file in file list. And what do I want to do? I want to classify the doc. And there we go. Responsibility, unknown, enrollment, and our error. Okay. I think that's probably almost enough. There is one other thing that isn't necessarily having to do with this video, but I'll just throw it in anyway. Because we're operating on a list and using a function, you can use the multiprocessing module. You can use pooling to use your CPU cores, kind of run those in parallel and speed it up. You really won't see that with this, but imagine you have thousands, tens of thousands, hundreds of thousands of files, maybe even over 1 million. In that case, you might want to look into distributed computing, where you're breaking up the data, passing it to different machines out there, and having each one of those workers work on a piece. But until you reach the limits of your local machine, you might want to be familiar with multiprocessing. And I also want from multiprocessing, import pool. Let's see, CPU count equals multiprocessing dot CPU count. That'll work. One's a function, one's a variable. Run that, and let's see how many cores I have. Okay, one other thing I should mention: if you're going to be processing a lot of data on your local machine and you still want to use your machine while you are doing that, do not use what I just showed, because that's going to use every core on your CPU, which will make your machine very slow, possibly inoperable, and may lead to lots of unpredictable behavior. I know from experience. So you could do -2, give yourself 2 cores, you deserve it. And if we look now, that's 4. And we can do with pool, and you can put an integer in here, 4, 3, anything less than your CPU core count. But I made that variable so we can pass it in. And what are we going to do? We are actually going to map a function. It takes the function name, so you don't need the parentheses. We're not going to call it. It's smart enough to know my first argument is going to be a function. And in this case, it's going to be classify doc. And what do we want to iterate over? Our list, which is file list. And I can already tell you right now, this is going to complete very quickly and not run, or it's going to just run forever. So what happened there? The answer is I really don't know. But I do know there are issues with what's called the GIL, the Global Interpreter Lock, when you're on Windows. So if you're doing this, you can do it on Windows, but it does need to be in underneath the main portion. That if name equals main, it needs to know it's running as the main program, I believe. We can fix that by making a classify doc Python file. And what do we want? we'll need that. Import. Just grabbing all my imports here. Best practice is to keep those at the top. And just two more. And just as best practice, you usually do Python built-in packages, third-party packages, multiprocessing is built-in, and then any third-party packages, ones that you have downloaded, and then anything after that, if you make your own custom packages, those would go next. Shortest to longest, and then divided into those three sections. I don't know where I picked that up. It was years ago. I'm not really sure if it still applies, but I try to stick with that. So we are going to make our function here, and then we are going to go ahead and make our file list. And down here, we just need to do if name equals main. And if you're not familiar with this, you can just kind of wave your hand at it. It's very good to know, but the important thing I want you to keep in mind is if you're using the multiprocessing pool, you want to put that with pool underneath that. And fix the indentation. Actually, needs to be moved over. And we make this a function, get files. And after it's I'll go ahead and make that list still. I was thinking about doing a list comprehension, but you know what? Let's just return file list. And we can just say files equals get files, CPU count equals multiprocessing, CPU count. Now that doesn't look the prettiest, but that'll probably work. All right, and here we have our classified docs program. Let's see if that runs. No. It's because I've got these here. Okay, I see what I did there. I need to actually use the pool and use the map method from pool. So that was my bad. All right, so now we see those have moved. We can go ahead and reset those here real quick. If you were actually testing this with a lot of files, you could modify something similar to this. I don't know, call it reset. Go one directory deep and say, hey, find me all PNGs, JPEGs, TIFF files, things like that, and move them back to the current directory. I just wanted to show also that if you go ahead and run that here, let me go ahead and rerun these cells. I was doing a quick bit of troubleshooting there. Make sure I've got my file list. Let's see. And it doesn't really matter because it's going to be a short run, or it will just run forever, because I believe what's happening is it's hitting locks, or at least it thinks it is, and it's backing off, and then it's trying to run another one, and it's just getting confused in kind of a traffic jam that way. And then that's a good demonstration of why, when you're on Windows at least, and let me go ahead and let this crash to a fiery death. If we go ahead and move that down to the bottom here, we can leave that there, that's fine. It'll run just fine. But again, that's all for this video. Hopefully this gave you a nice introduction of how you can set up Tesseract on Windows. As always, I highly recommend people use Linux. It's much easier, not as much hassle at all. How you can OCR documents, extract the printed text from that, and maybe gets the idea juices flowing a little bit about if you want to make a data engineering or data science project, you could use things like this, as well as thinking about scale and how you can divide your problem into units of work and how you can speed up processing by doing so. But that's it for this video, and I will see you in another one.